Hi everyone, this will be an optional module for you to take in order to better understand what generative AI is, what LLMs are, and how agents fit into the picture. We'll go through 4 separate videos, but just to be clear, this is a completely optional module. If you already know the basis of these things, you can go ahead and skip it. We'll also be going through it very quickly. If you do want a more in-depth view of this, there's another course that goes into what generative AI is, how it works, and talks a little bit more about the theory of generative AI, LLMs, and agents. But let's get right into it. What is generative AI and how does it fit into the bigger picture? Well, there's something called artificial intelligence, the idea being creating systems that mimic human behavior. So, artificial intelligence can be as very simple as creating an if statement. If you're hungry, you go eat. If not, you go sleep. That is an example of artificial intelligence. It may not be the most intelligent system, but it is a system that can be used to predict human behavior. Next, inside that artificial intelligence bucket, you have something called machine learning. The difference here is machine learning is a way to train systems without being told explicit instructions. So instead of explicitly defining what instructions a computer should take, instead you give the computer, here are the inputs, here are the outputs, come up with a way or a process to determine the outputs based on the inputs, right? So these are your regression models. These are the machine learning models that you typically see in self-driving cars and things like that. You get an input, you give it output, and then it kind of finds its own way after that. You then have deep learning, and really the difference between deep learning and machine learning, even though deep learning is a subset of machine learning, is that the what I would say is that the process between your inputs and outputs gets a little bit dismayed. Deep learning primarily happens through a process or a schema called neural networks, where you basically give a system a bunch of inputs and then you let itself tune these different nodes to determine what the output should be. And in deep learning, what gets really troubling sometimes is you don't know how the computer is thinking about processing the inputs into the outputs. All you see is a black box model where you have inputs, you then have some nodes that tweak in certain ways, and then you get an output. But deep learning is definitely the best way right now to capture lots of good nuances in very difficult problems. So, if we need to do any sort of image recognition tasks, for example, deep learning is the way to do it. Deep learning takes values of all those pixels of your image, feeds it through a neural network, and then output comes what the image is: a bird, a plane, whatever. Okay. It's also used in autonomous vehicles. And then finally, it's also used in generative AI technology. Okay. Generative AI technology is simply deep learning models that produce various types of content. That content can be text, images, audio, or so on and so forth. Again, the big difference here is that it's technology not to necessarily predict an outcome, but it's to produce content. All right. Now, why did Gen AI blow up in the past few years? Well, there's 3 main reasons. The first is the neural network architecture. Um, the idea here is it is a lot easier to train models now that we have these neural networks, and especially now that we have a capacity called transformers. This is outside the scope of this course, but in essence, transformers are a way to take lots of data and analyze them in a way where we can produce one output from them. That is a very, very simplified model of them, but transformers are a technology that blew up very recently that allows us, or a model that allows the model to input lots of data. Okay. There's also a big increase in compute power. If you think about it, the best way I like to think about it is think about graphics for games, right? When you think about graphics for video games, the act of creating graphics is just solving very complex mathematical equations very quickly. For example, if you want to render a shadow, you need to determine where the light source is, where the object is, how it reflects on different surfaces. Those are all math equations. And think about how much better video game graphics have gotten from the past 10 to 15 years. The reason that they've gone so much better is because that there's been a generally a big increase in compute power. There are these machines, these GPUs that can process trillions of mathematical operations in seconds. And in doing so, it allows us to create neural networks a lot quicker than we ever had before. Finally, there's been an increase in available data. That's really grown as well. I think there was a great stat that, every 5 years, the number of available data doubles because the velocity of data just keeps increasing and increasing. And one thing that a neural network needs is a lot of data to basically tune all of these different layers in a neural network. Okay. There's obviously lots of drawbacks to generative AI. One of the big ones is it's a black box. I put it second here, but that is a big, big limitation that we've already spoken about. Because we're using neural networks, it blurs the lines between how you get from input to output. You can feed an input, you can see what comes out the other side, but you don't know what's going on in its brain. It's very, very difficult to ascertain it. It's the reason why typically in financial models, or fraud models, you typically don't have neural networks being used, even though they produce better outcomes, because regulators want you to explain how the models work to ensure that there's no biases. But you can't do that if it's a black box model. The other thing is limitations and bias. There's definitely lots of limitations around accuracy for these deep learning generative AI models. They can sound very confident, but be very, very wrong. And they're as good as their training data. If the training data is biased, then generative AI outcomes and outputs will also be biased. This all leads to harmful uses of generative AI, things that bad actors can use to spread misinformation, even things like creating deepfakes and proliferate scams. So, in summary, when you're using any sort of Gen AI technology, especially in business and really important outcomes, you should have two things in mind. The first thing is be excited. The Gen AI technology just keeps getting better and better and better. And key thing, it keeps getting more democratized. Before, it was only available to Microsoft, Google's, and very, very well funded startups. Now it's available to everyone for a few cents and with a computer, which is awesome. Okay. It's also good to be excited because it is the accepted opinion that those that use Gen AI will outpace those that don't because it is such a revolutionary technology in terms of improving productivity. Okay? At the same time, it's good to be cautious. We've already spoken about the limitations, biases, and black box model related to it. It's also an ethical nightmare, particularly limiting it in morally nuanced situations. For example, should it be used in a doctor patient setting to summarize information? Very, very, um, very well performed, but the idea of the limitations and biases in black box can work against it. So be excited and be cautious. And what I always used to say is that humans must still be in the loop. But now I've crossed out must and replaced it with humans should still be in the loop for critical processes. And the reason why I'm changed my tune here is because it's gotten so much better than it has before. Before, LLMs would hallucinate a lot. Now they don't really do that much. So it's still my opinion that for critical processes, you want to use it as a tool, not to replace an existing process outright. So humans should still be in the loop for critical processes. For non-critical processes, those are the ones that are definitely prime for Gen AI to take over and be more efficient. Okay, so that's a quick primer on Gen AI. In the next video, we'll talk about LLMs in general. We'll talk about the limitations of LLMs and how you can use things like RAG and tools to overcome them. And then we'll talk about the difference between a workflow and an AI agent to kind of wrap this up. If this was very informative to you and you want to go more into this type of lecturing, then there's another course out there. It's called Generative AI for Business Leaders. All right? Awesome.